I did have a few slides I put together. I like writing code better than I like putting together PowerPoints, so I will do this very quickly, and I'm sorry that they're so ugly. I'm going to quickly show to you Sokatoa, which is a GPU Vulkan profiler that my team has been working on. By the way, my name is Warren Paul. I am the tools lead at Samsung Austin Research Center, where we create the Xclipse GPU that goes into some of our smartphones and some other technologies that we're working on. So when we came into this, our goal was to create a really good GPU performance tool for both graphics and compute. We wanted to be vendor neutral, so any GPU vendor could plug in the smarts for their technology, and the user gets a consistent experience, look and feel across the board. We also want to open source this project. We have not done so yet. Framework needs, we wanted something fresh with modern technologies. We'd like it to be able to run on desktop or hosted in the cloud. We wanted complete flexibility and customization so we can completely brand it and do whatever we want with it. And obviously, we wanted a very active open source community, which we think Theia has. Some of the core technologies we use in the product are Perfetto, Graphics Reconstruct, Vulkan, and SQLite. My team, we've been working with Eclipse for over 20 years. We've done many Eclipse-based IDE products. We've done lots of RCP-based applications. We're very familiar with all the technologies for that, as well as a lot of backend stuff in C++. Coming into this, we had very little to no experience with TypeScript, React, Webpack, Electronic, etc. The solution we came up with, of course, was Theia. Otherwise, we wouldn't be here today. We worked a lot with Eclipse Source on this product, and if you've never worked with them before, they are awesome. Some of the contributions we made to Theia thus far, the ability to contribute backend only extensions. For example, a GPU vendor wants to integrate some logic that's specific to their GPU technology. We have a common front end, so it's really just a backend plugin providing data that's driving a common user interface. We've also made some bug fixes. There's plenty more to come on that. With that said, I'm going to go ahead and do a quick demo for you. If I can figure that out. It says I'm already sharing my screen. Oh, always something. Always something. Share my screen, and then I closed. Oh, I shared the window, the PowerPoint window, and now I'm trying to share a different window, a different process. Right, there's no way to stop sharing once I close the window. Let's see anything. I'm just going to pop. Okay, sorry, I had to pop out to rejoin so I could share the demo here. All right, so this is Sokatoa. This is the GPU profile I was speaking of. I'm just going to do a quick demo. So this is all based on Theia. You can see that most of the sort of window trim and stuff looks the same. We've added a few things to the taskbar. We've added our own views. If you look at our code, this is not an IDE. We have stripped out everything that would make it look like an IDE. So we're really just using this as like a Theia-based RCP application. We do use the settings and everything, but we've sort of hidden everything that's IDE centric because most of those things don't make sense for this particular product. I'm gonna give you a quick demo. So what we're gonna do is I have an Android device connected to my PC via USB, and I can select a package to launch that I want to capture information for. Give it a name, give it some notes. This is the device I have connected. I can select various options. So Perfetto is basically the performance data we're collecting from the device itself, and GFXR gives us the ability to sort of record all the API calls, the Vulkan API calls, and then play them back later to do things like capture frame images and geometry and you name it. Also, we can edit and replace shaders and replay those to see what sort of quick experiments to see what that might look like. So I'm going to go ahead and the app has now been launched on my phone. I'm going to just do a quick start. And when I stop, it's going to pull the files from the device and start parsing them. So we basically created a new profile over here, and then this is the baseline that's been opened here. This is the Perfetto data. It's showing basically everything that's been happening on the CPU and GPU during the time I did a capture. And for some reason, oh, by the way, this is a build fresh off the presses from this morning, so I apologize. There will be some bugs, but we are, and I tested it right before this with this app, and that didn't happen. So anyway, the idea is you can quickly look at the frames, what's happening here. You can drill into the frame by double clicking on it, and then you see all the activity for just that frame. You can look at GPU activity. If anyone's familiar with graphics APIs, this is basically the actual draw calls that were happening on the device for this particular frame. We do give you some performance numbers as well. So a summary of, for example, this subpass, the total duration for it, how busy the GPU was. And these are all the performance counters that you can look at that come from this particular device. Obviously, all these are GPU specific. So these are coming in sort of by extension already. If you want to know exactly what the Vulkan API looks like for this frame, you can see all that activity here. If you select the draw call, you can actually see the pipeline stages, the Vulkan state at the beginning of this draw call, the vertex shader, fragment shader, and then at the end state. So I can collapse this tree, I can collapse this to give you a little bit more room here, but you can see here, this is the actual mesh that's used to render this frame. And there's also a this is the texture that's being rendered for that frame. If you want to, you can actually come in here, and this is the actual shader code. Well, this is a cross-compiled version of what the shader code probably looks like. If this is your own application, you can easily associate your own shader source code with it. But if I want to, I can sort of look at some of the static analysis done on this and see, am I writing the shader optimally or not? I can also come in here and click this edit button, and I can tweak the code. I'm just going to put in a little fix me here. When I save it, it automatically compiles it. You can see that we're using the built-in console window for our compilation output. Anyway, I can actually do a new replay with this different shader. So what it's basically going to do is similar options to my initial my initial capture, but now I get to select shader version. So I can modify as many shaders as I want, and when I replay, it's going to use the modified shader instead, and I can actually compare not only the performance data, but the actual rendered output as well. So I can use this as a debugger tool or as a profiler tool. So here we have the replay, and I can see similar activity for what's happening on the GPU. I can view the performance counters, and I can even come back in here. I can actually compare these two things. It's supposed to be able to compare these things. Sorry about that. Like I said, it's a fresh build. In any case, when you compare these two things, you can basically look at them synced up in either side by side or above and below, and you can zoom in and zoom out, and they'll be in sync. Anyway, just wanted to share this. This is not a released product yet; it's still in development. But yeah, so far we're really happy with Theia, and I think we've made a good choice. And just wanted to thank everyone in the community for all their hard work.